morning, everyone. Are you able to hear me?
Yes, ma'am, you are audible.
Okay. Okay, sir. Thank you, sir. Welcome to the second day of our faculty development program. We hope you had an insightful first day and are excited for another enriching session today. It is an honor to introduce our esteemed speaker, Dr. G.A. Preeti Anandchari, who brings with her a wealth of experience and expertise in the field of AI, big data, and mobile computing. Dr. Preeti earned her PhD from Periyar University, Salem, Tamil Nadu, and is currently serving as an assistant professor in the AI and Big Data department at Endicott College of International Studies, Wuzong University, South Korea. With 14 years of teaching experience, she has made significant contribution to academia and research. She has worked as an assistant professor at VIT Bhopal University, Madhya Pradesh, and as a guest lecturer in the Department of Computer Science at Periyar University. Her research interest is spanned across mobile computing, sensor techniques, wireless technology, big data analytics, machine learning, and robotics. She has authored books on Python and big data analytics with award at the International Conference on Advances in Engineering and Technology. Beyond research, she has been an invited speaker at numerous FDPs and conferences, sharing her insight with the academia and research community. We are truly privileged to have her with us today. Dr. Preeti, we eagerly look forward to your insights. Dr. Preeti, ma'am, you can begin your session.
Okay. Can you hear me now?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay,
ma'am.
okay, okay. So I will share my PPT. So can you see my PPT now?
Yes,
Yeah,
ma'am.
ma'am, we can
It's
see.
Yeah.
visible.
Okay, okay. So today I am going to talk about big data in education and curriculum design. Um, so actually I think there is no need to introduce myself. It has been introduced already. But the thing is I'm in India, I'm in vacation. So that's why you can hear some noise. I'm sorry for that. I'm staying in the main city. So that's why there will be a noise. So if you see what I'm going to cover in this presentation is I'm going to discuss about some big data introduction. What is mean by big data, how we are creating this big data, and what are the tools. I'm not going to do like in-depth insights about the Hadoop tools or other big data tools because it is a vast ocean. If we go deep, then I have to talk about each and every tool, about the big data tool. So I will just give only some overview about Hadoop, and then we will talk about how this big data will be relevant in higher education institution, how we are using it currently. Okay, and then how it will be useful for research as well, how this big data analytics is very helpful in research as well as in real time in like a Coursera, other Udemy courses, how they are managing this big data. That's what we are going to see. I'm going to show simple examples. Even though the term is big data, I have taken only small data to show examples. Okay. Uh, so if you see uh, big data in education, so what does this mean for education? Just a second. Yeah. So first, if you see big data um, in education means, so who are all the stakeholders in education? If you see the students, the faculties, the programs, the courses, and the university, the institutions. So these are the factors which will be getting affected. These are the people and these are the main stakeholders which will be getting affected. We have to see meaningful insight about the students, faculties and others. Okay, so the real-time data, how we are going to get the real-time data, the dashboards, like if you see in Korea, we are using LMS, Learning Management System. Like that, I think in India, mostly they are using this Moodle, right? So in the Moodle, we used to put all the PPTs, all the learning materials, and the students will access the syllabus and everything. And we used to give the homework and other things. So that's how we will communicate with the students. That's how we know whether how much time the students are spending their like the academic activities. Okay, and we can do the statistical analysis through this. We can apply machine learning algorithm when we get the data from this LMS and Moodle systems, and you can do this data modeling. We can do the structure and we can see visualization, that is data modeling, and then data mining, that is extracting the pattern. So we have a big data, we are creating a big data through this kind of LMS, learning management system, and Moodle. Okay, and then if you see transforming education, how we are transforming education. So in a traditional way, we use this blackboards usually, but nowadays we are using this Moodle. So when we are using Moodle, we are creating lots of data. Okay, this is transforming education. So the grades, the outcome. So what we are doing by using this Moodle, through the Moodle, we will come to know that how many students are actively participating or actively doing, submitting the homework and everything. So when we know that who are all not spending time, who are all the weak students and other things, so that we can improve our level of teaching. Also we can give some extra courses or extra classes for those weak students. So that's how we can improve. That's how we are transforming the education. And also we can introduce flip learning actually. We are doing that in Korea. Flip learning in the sense we will put some videos and we have this, whether the students have watched the video or not. We will get the data in live. So if they have watched the video, and then we can give some quiz based on that video, so that they cannot avoid anything. We are making forcefully the students to engage themselves, and then they will get the knowledge right back there. So that we have all the evidence whether the student is spending the quality time in education or not. Okay, and then this becomes lifelong learning. So then finally we have this personalized learning. So for example, if you see the LEAD code, so if you know the LEAD code, most of the people, those who are practicing this data science things or machine learning algorithms, they go for this Python LEAD code, those who are preparing for this interviews. So they have this three setup, like beginner level, intermediate level and advanced level. Okay, so in the beginner level, it will be some easy questions will be there, and the intermediate level, there will be some middle level questions will be there, and then the difficulty level. So like that, personalized learning means for the weak students, we can give some easy questions, and train them up with that easy questions. Then they can go to the second level like that. So this is the personalized learning. So what we are getting through the big data in education, we are transforming the education, we have the LMS system, and then we are getting the insightful data. Through the insightful data, we are extracting the data and we are getting the pattern, we are getting the knowledge, and then we can identify the weak students, we can encourage those who are learning actively, and we can give different set of questions for all different levels of students. So big data analytics in education market. So the forecast in 2030, how it will be. So the global big data analytics in education market was valued at 13.58 billion in 2020. Now in 2030, they are saying that it will be 57.14 billion in 2030. So this is compound annual growth rate. Okay, that's what CAGR of 15.3%, and in 2040 it is going to double. Okay, so the global big data analytics in education is segmented. How we are going to segment? Already we know that we have segmented like this. Now if you see, there are 4 segments. First one is component, next is the deployment model, application, sector and region. So the component, what is the component means? So the component is divided into 2 types, software and services. Because as I told you, we are using LMS and Moodle. So that is the software. Okay. And then on the basis of deployment model, if you see, it is categorized into on-premise and cloud. See, even in our university, the spring semester and fall semester, we give this offline classes. And also there is some courses we give in online. Okay. In the winter and summer, most of the courses will be online. So what happens in the online classes, we cannot make sure that the students are listening properly or not, even though if we ask them to turn on their cameras and other things. So that's in that case, what we do, we give some homework, the quiz, like we have this engagement section. Okay, like how much time they have spent online, all this data we are getting. Okay, through that we can analyze that whether they have spent the quality time listening to the class or not. We give in-class activity. After the class, immediately we will give quiz and they have to answer them immediately. So that way we are making the students to engage in the classes more actively. Okay. So the applications converted in the study include the behavioral detection, skill assessment, course recommendation, student attrition rate, and many other factors you can add actually. Okay. So by sector, if you see, by sector means it is easy. K-12, it will be preschool, higher education, college, like that you can divide. Okay. So what we are doing after dividing that into segments. So this study that provides the Porter's 5-force analysis of this big data analytics, so that they can understand the impact of various factors like bargaining the power of suppliers, the competitive intensity of competitors, threat of new entrants, all these things you can analyze. Okay, so this is the final summary of this big data analytics in education market actually. So if you see, the report highlights, as I told you, by component it is software and services. Deployment model will be on-premise, that is class, physical class or online class. Okay. And then by application means behavior detection, skill assessment, whether the student is skillful or not. By giving the quiz and other things, we can assess that. And the course recommendation, like if a student has attended your course in previous semester, whether how likely he is going to recommend to his friend or his junior, that is course recommendation. It will be based on many other factors because student feedback will be there, and the ratings and student attrition rate detection and other factors. By sector, as I told you, K-12, preschool and higher education, we can say. So the region, all the regions included, not only America, Europe, Asia and other regions in the world. So what is the key market player? Key market player is, these are all the companies actually. This Blackboard Incorporation, Latent View Analytics, Microsoft Corporation, Oracle Corporation, they support both industry as well as academics. Okay, so they are playing high level in big data analytics and maintaining the big data, data modeling and other things. So if you see, this is the final visualization. Global big data analytics in education market, if you see, in 2030, it is projected, it is forecasted that 57.14 billion will be the CAGR, that is compound annual growth rate of this big data analyst. So it is not because of this topic I am talking. If you see what is the top 10 trending required jobs, big data analyst is in the second or first position I have seen. I saw this in the LinkedIn. Okay, so if you see this, most of the people will think that data science means you learn Python, you learn machine learning, deep learning and other things. If you take big data have various tools actually, like DevOps. Okay, so big data, you can learn Hadoop and then you can learn Spark, and there are many tools. Big query is there, big table, many things are there. Okay, cloud computing. Okay, because mostly these days everyone is like most of the industries, we are all using cloud based storage only, but still you have to learn about Hadoop. It is because then only you can understand how the distributed storage system works. Okay, so then you can understand how this cloud computing also works. Okay, now if you see what is big data. So mostly if you see the example we used to give for big data is Google. So why we are giving the example, simple example is Google. Because when you search for something, it gives lots and lots of information. Nowadays, I think most of us are not using Google. Most of us are using ChatGPT, Gemini and other AI tools, right? So big data is a big thing earlier and also now. So the first organizations to use were online and startup firms. So those who were using the big data were Google, eBay, LinkedIn, Facebook. They were the ones who used from the beginning. They are using the big data. In 2013, I think this term was becoming popular in 2013 from 2012 or 13. Okay. So from that time onwards, the Google is using this big data. Like many new IT techniques, big data will bring cost reduction and improvements for performing the computing task. So for analyzing big data, we are using some different tools. We are not using any traditional database softwares. Okay. We will see why we are using such things. So first of all, what is big data means? Big data is similar to small data, okay, but bigger in size. Big data is nothing different. It is also a same data, okay, but the size is very big. That's why it is big data. So having data bigger, it requires different approaches. As I told you, techniques, tools and architecture is totally different. It's not the traditional way, okay, and aim to solve new problems or old problems in a better way. That's what we are going to see, analyze. So big data generates value from the storage and processing of very large quantities of digital information. You cannot process it through the traditional computing power. So if you see, digital universe approaches high. If you see in 2025, EV means electrical vehicle. Holland is a company. They have given the estimates. Every year they will find the estimate, like how much increase is there in the electrical vehicles, IoT devices, and the digital universe and everything. New technology platform. So how many new technical platforms are there? In 2025 it is 2,500. In 2030 it is going to be 5,000. So every 5 years there will be 2,500 new IT platforms are there. So in total, if you see, in 2025, currently we have 6,746 zettabytes of data. We are creating, we are consuming and everything. But if you project it to 2040, you can see that it is going to be 74,000 zettabytes in 2040. So that's why we still talk about big data. Even though we know we have cloud, we have everything, but still it is going to be very, very big. We need more and more capacity devices to maintain this big data. That's why still we are talking about big data. So if you see in 2025, we have this 7,000 something zettabytes. 2040, in 15 years, it is going to be 74,000 zettabytes, which is 11% larger than currently what we have now. So what is zettabyte? Zettabyte is 1 trillion gigabytes. Okay. So that much big it is going to be in the future. So we don't know that currently the techniques and tools we are following will be useful in that after 15 years. Okay. So now we will see big data. What are all the big companies they are creating this big data like in every day. So if you see NYSE, New York Stock Exchange, this New York Stock Exchange generates 1 TB of new trade data every day. Okay, every day it is creating 1 TB of new trade data. So if you see in a day or in a minute how much big data we are creating, how it is getting stored, how we are going to deal with it. Okay, so if you see Walmart, I think everyone knows about Walmart. I think in Bangalore also Walmart is there. The company is there, I hope so. So the Walmart handles more than 1 million customer transactions every hour. It's not every day, it's every hour. Okay, and Facebook handles 40 billion photos from its user base. And then decoding the human genome, originally it took 10 years to process. Now it can be achieved in 1 week. So why we need to decode this human genome? So because human genome is a gene expression data. If we decode this, when we research on this DNA gene data, we can come to know that why some diseases are hereditary, how we can treat that disease. This is totally about medical field, medical healthcare sector, but still they are doing it. Earlier it took 10 years, but now since we have this ML and DL support, it can be achieved in 1 week. Okay. So now if you see big data market forecast worldwide from 2011, because big data just started from 2010-11 we can say, okay, because Hadoop was the first tool for analyzing the big data. So if you see segment by segment, we have the storage, we have NoSQL, Hadoop, we have SQL also, we have data management. From 2011 you can see that the picture, you can see still in 2026 we have this Hadoop usage, because some of the data analyst or a big data analyst, they used to say that Hadoop has been nobody is using, only in academics they are using. It's not the thing. If you do a proper research, Hadoop is the base, because some of them used to say that we can learn Python, no need to learn C or C++. I will suggest first learn C, then go to Python, because first if you learn Python, then if you learn any programming languages, it is going to be hard. Okay, first learn C. So C if you learn, as I told you that we are not going to be data scientists. Each and everyone is not going to be a data scientist. Okay, some of them will be hardware engineers, some of them will be some web developers or something. So if you want to know about how the chip designing is done, GPUs, like you are playing games, most of the students are playing games, right? So how we are maintaining, earlier we had only CPU, now we are talking about GPU. So how the capacity we got through the GPU. So for that you must have the knowledge of C and C++. Okay, so like that, when you are dealing with the big data, when you want to be a big data analyst, you must have the knowledge of Hadoop, how we are storing the Hadoop distributed file system. So if you see, Hadoop is still there, Hadoop, and then this, I think this one is apps and analytics, big data analytics. These two are having contributing major role even in 2025 and 2026. Okay. So now if you see types of data, we talk about big data. There are two types, quantitative data, qualitative data. Quantitative data means it is measurable. Qualitative means it is like fuzzy. You cannot measure it. It is just descriptive. Okay. Measurable data, that is quantitative data, is collected through measuring things that have fixed reality. Okay. So you can say it in units like 1 kilo, or you can say, I'm sorry for the disturbance, it will be you can say in some crisp numbers. That is a quantitative data. For the qualitative data, it will be collected through observations or field work or focus groups. Like we used to give this survey. Okay, some of them may feel good, some of them may feel bad about anything or an app or something. Or even you can take a simple example, a movie. So everyone cannot like a particular movie. Some of them will have some negative review, some of them will have positive review. It is like that. So this qualitative data is open-ended and this quantitative data is close-ended. These are the types of data. We can say quantitative data is descriptive, like a descriptive statistics. You can measure it with quantitative data. For the qualitative data, inferential statistics. You can infer knowledge from it. Okay. So finally, what is big data means? Data that is too large or too complex to be managed using the traditional data processing techniques and analysis and storage techniques. That is big data. For that we need a new technique. We cannot use the traditional technique. Okay, so whenever we talk about big data, people used to say that there are 3 V's, 4 V's, and nowadays they are saying that there are 7 V's. But in the beginning, it was 3 V's, that is volume, variety, and velocity. That was the term they used to say. Volume. What is volume? Volume means the amount of data. Okay. Variety, the types of data. So even though we talk about big data means if you take, as I told you, the internet, the digital universe, we cannot say there is only one format in a data. There are varieties of format. PDF is there, Word is there, streaming data are there. Okay. And velocity, the frequency of data, like how frequently the data being generated or how frequently the same data appears, like that. Veracity means the quality of data. The data is like having the quality or not, or it is just a fraudulent data or no useless data, like that. So these are the 4 V's. Okay. Volume, as I told you, the first V is volume, the scale of data. So we are talking big data, but when we are calling it as big data, if it is 1 bit, we will say 1 bit, right? If it is 1 byte or 2 byte, 3 byte, we used to say bytes. Then kilobytes. Then we used to say KB, some 4 GB data, we used to say 4 GB data, we are not calling it as big data, right? And even TB. After TB, when it became petabytes, we used to call it as big data. Okay. So KB also we mention as KB, then GB, then TB, and after that we stopped mentioning as like petabyte, we call it as big data. Okay. So whenever you call it as big data, if it is petabytes, then it is big data. After that we have this exabyte, zettabyte and yottabyte, many measures are there. So volume, scale of data, if you see this 90% of today's data has been created in just last 2 years. Okay, so whatever data we are creating, that has been created within last 2 years only. So every day we create 2.5 quintillion bytes of data, or enough to fill 10 million Blu-ray discs. So how we are creating? If you ask me, I will say no, I'm not creating such data, but unknowingly we are creating very big data. So for example, I have my laptop, I have my Samsung pad, I have my 2 mobiles are there, right? My Samsung pad and my laptop, my mobile, even my old mobile. In all that, I have my Facebook connection. Yeah, I have my mail, I have Instagram, Even actually in Korea we have Kakao. They won't use this WhatsApp. Okay. So Kakao is like a messenger. Through that they used to communicate. So that is also there. Okay. Like that we have social media connections. So what happens? Suppose if I like some of my friends' pictures, okay, in Facebook, what I will do, I will just click the button. Okay, I'm clicking the button. I will think that is simple action. But what happens? I have some 300 connections. I'm liking my friend's picture. So my friend is having 400 connections. Okay, so what happens? All this 400 connections has to be updated, right? So what I'm doing, I'm creating a very big data unknowingly. Even though I'm thinking that I'm just clicking the like button, it has to be updated in all the friends links because my friend is having 400 connections. Okay. So how it is possible? It is through the big data tool. There is a tool called Apache Kafka. Okay. So this Kafka is like an agent. It is having some techniques like topic management. Okay, producer consumer relationships are there. So whatever you are doing, that action has to be distributed immediately to all the connections. So in that case we are creating a big data. That's why here they say that every day we create 2.5 quintillion bytes of data. Okay, so 35 zettabytes, that is 35 trillion gigabyte of data were created by 2020, 5 years before. Okay, and an increase of 44 times from 2010. So in 2010 it was equivalent to 5200 gigabytes. So if you see from 2010 to 2020 it was a tremendous. Could you please mute by yourself?
After that, I decide whether a hacker can hack or it will not hack.
Yeah. And so if you see from 2010 to 2020, there is a tremendous increase. Okay. Now it is going to be a very huge increase in the future also. That's why we need like big devices, big capacity devices for handling this big data. Okay. Most companies in the US have over 100 terabytes of data stored. So that's why we are talking about this statistics. Why I am telling this? Why I am telling this 2.5 quintillion, 35 trillion, all these things, because we are creating so much data unknowingly, and we need devices to maintain those data. Okay. So if you see, the next V is variety, different forms of data. So see, in 2010 we know that Microsoft Word, PPT was there, right? PDF file was there. And if you take image, we had PNG image, JPEG image, bitmap image, right? So these were the images, and GIF image. These are the only formats we know. But today, if you see, even we are in academics, even I am also an academician, like all other faculty members, those who are attending, you are also academician and industry persons. We also don't know how many formats are available worldwide. Only after coming to Korea, I came to know that there is a format which is called HWP. All the Koreans are using only that HWP file. Nobody is using mostly Word file. Only foreigners, those who are there, we are using Word file. Most of the files they will send as HWP. HWP is a Hangul word processor. Hangul means Korean. Okay, Korean word processor is there. They will use only those format. So if you see, there are varieties of data. Okay. So in LinkedIn, it will create a type of data. That is a format. Facebook will create a type of data. This Twitter, Instagram, they will create some different varieties of data. All this variety, all this formats has to be unified, standardized into one format for processing. Okay. For that also we have tool. Okay. So what happens in an internet minute? As I told you, if you see 16.2 million texts were sent in an internet minute, and 231 million mails are sent in an internet minute, in 1 minute in internet. and 3.47 million YouTubes will be watched in like in one internet minute. And also if you see these days we have started shopping online, right? Earlier we never believed that online shopping is very like whatever you shop online will not be that feasible. But these days if you see in Korea there is a coupon, like how we here we use this Flipkart and Amazon, like that in coupon. I mean in Korea we have coupon, most of the people use coupon, and that is like Amazon in Korea. Okay, so 6.6 million people shopping online, and 6.3 million Google search is there in 1 minute. And you can see all other activities in 1 minute. These much of big data we are creating. Okay, so that's why we need more and more capable devices, or we need more and more good algorithms for analyzing the big data. Okay. So next, if you see the velocity analysis of streaming data. So analysis of streaming data, what is a streaming data actually? You can take sensor data. So most of the buildings have this CCTV. If you see in Korea, each and every house will have CCTV, not only the shops. But in India, if you see most of the shops, they have CCTV. In home, also some of them are having CCTV for the security purpose. So what happens, the CCTV will be on for 24 hours and it will be running, it will be creating the sensor data, right? So all the sensor data is there. Streaming financial transaction is also a sensor data, and you can say that what is the other streaming data? Yeah, this Twitter, Facebook, this is also a streaming data, because when I open my Instagram, I can see some post, but after some time again if I open my Instagram, it will be a new post, right? So that is also a streaming type of data. So velocity, the analysis of streaming data is very huge. This is also a type of big data. Okay. And veracity. Okay, we are talking about this as I told you, the Facebook, Instagram and other things. Is that a trustworthy data, or is it a useful data? Or trustworthiness means you can say that you are getting some data, you have to check whether from where it is coming from, its authenticity, it is not a fraudulent data, all these things. Veracity is also another thing. Origin of the data, authenticity of the data, trustworthiness of the data, completeness and integrity. Okay, integrity means the more or less completeness and integrity is same. Accuracy, the data is accurate or not, the data is coming from the trusted source or not. So this is the veracity. Okay. So now we have talked about this volume, variety, velocity, veracity. These are the V's concerning the big data. And there is another V which is called value. Okay. So we are talking about all this data, whether these data has value. If I like someone's picture in the Facebook, it is not a big value, right? So the data must have the value, then only it will be useful, then only it will be analyzed properly. Or even if the CCTV camera is creating sensor data, it is recording all the activities, but it will not be that useful, right? Only if there is something happening, some incident happening, then we can get. But for that also we have to run the camera and see. So other data will be irrelevant. So now if you see big data, how it will be useful in research, what we can do research in a big data. So we can take this big data mining. I think most of us know about this a priori algorithm, right? So data mining means we know that extracting the knowledge, right? Big data mining means extracting knowledge from big data. That's the meaning. Collect big data or obtain access to a repository. So there are many repositories available these days. We can obtain the data, big data from that repository, and then perform data analysis to explore patterns. So what we do, we just explore pattern. That's what we are going to do. So what is the pattern actually? Pattern recognition. Then we do this predictive analytics. Pattern recognition means nothing but, as you can see from the picture, customer who bought this item also bought this item. It means the customer who bought banana also bought milk. Like that. If we see the pattern, it will be very much useful for the business, right? So we can make the productivity, you can ask the production unit to create like that product in a good term, or we can place the products in the proper way. So if someone is buying banana, and the same person is buying the milk, if you see the same pattern repeated, then you can keep banana and milk together in the shelves. Okay, so this is how you can improve the business. So this is the pattern recognition. Okay, and then predictive analytics. Predictive analytics means you can predict that someone who is buying banana, definitely he is going to buy this milk or a bread or a carrot or something. This is the prediction. And identify potential correlations. Correlations mean nothing but again the same thing, like how many people buy the same item, that is correlation. And this analysis will be good enough for improving the business. So in research, if you see, this big data mining will be very much helpful when you find this pattern recognition by applying this algorithm. A priori algorithm is nothing but the correlation, the relevancy. And storing the big data. So now comes the main picture. Storing the big data means, first you must analyze the data characteristics, selecting data sources for analysis. So the data source from where the data is coming, okay, that is the analysis, and eliminating the redundant data. So if any duplication is there, then we will remove it through the pre-processing step. And then establishing the role of NoSQL. NoSQL means what? There is no structured query language. As I told you, big data, if you take Hadoop, you no need to create a table. In traditional way, what we do in RDBMS, in other database management system, whatever data is available, everything has to be converted into table. Then only you can process it, right? In Hadoop, you no need to create any table. Just give the Word file or whatever file. You can process any type of file. No need to convert anything into a table. So that's what establishing the role of NoSQL. NoSQL means there is no structure. You can process unstructured data as well. Okay. So now if you see the overview of big data stores, so the data models, the structure of the data in big data is key value pair. As you know that you have learned about this, in Python you have learned a dictionary, right? In dictionary what we have, key value pair. Like that key value pair we will create in Hadoop. It will process, the thing is it will process any unstructured data, but whatever data is there, that will be converted into key value pair, then only it will process. Okay, and you can process the graph data, document and column family data. Okay, and then for storing we have this Hadoop distributed file system. We have some other tools to deal with Hadoop, and we have Pig, we have Hive, and even we have Mahout. These are all the tools which is in the Hadoop ecosystem actually. So we will see one by one. I am not going to talk about Pig or Hive. I will just give one the introduction only about this HDFS. So selecting big data stores. So how you will select the big data store? Choosing the correct data stores based on your data characteristics. Moving code to the data. So usually if you see, I'm talking about Hadoop, I'm not talking about any other, because if you take AWS, that is a cloud storage, that is also dealing with a big data. Okay, here I'm talking about Hadoop only. Okay, so what happens in Hadoop is, if you have a very big data, the very big data will be divided into segments or divided into data chunks, okay, in equal size, okay, and then it will be sent and stored in a different computers, okay, computer cluster. For example, if you say that there are 10 computers connected together as a cluster. We will call it as a Hadoop cluster, HDFS cluster. Okay. So there will be one name node, other data nodes. Name node is like a master, data nodes is like a slave. Okay. 10 computers are there and there is a big data. That big data will be divided and stored in all the 10 computers. Okay. And one thing is, what you can do is you can add more and more computers in that cluster, or if you don't want, you can remove it. That is the easy process. If you have very big data, if you need more space, you can add more computers. It is not any supercomputer or any other some heavy workstation or anything. You can just use a normal computer as a cluster. So that's why we will call it as commodity software, commodity hardware. Commodity hardware means nothing but a normal laptop or a normal computer connected in a cluster, Hadoop cluster. Okay, so whatever free space is available, that can be used. So that's why we will call it as moving code to the data. We are not, because the big data is divided and stored in the chunks, stored in 10 computers, right? Now, if I want to process something, I will write the code and this code will be sent to all the 10 computers and it will do the operation. Then finally it will send back the results. So that is one advantage. So that's why, as I told you, even in Google, so you are searching something and immediately you are getting the result. How you are getting the result? They are using this Hadoop distribution file system because their data is distributed everywhere. Okay, it will go and fetch the information in all the computers and it will get the required result. Okay, implementing polyglot data store solution means it is not only making use of NoSQL, it will make use of SQL as well. Polyglot means different, you can say different programming languages or different database languages. Okay, you can say that I'm using SQL, I'm using MongoDB, I'm using this RDBMS and everything. Okay, together I'm making advantage of all the programming languages. And then this can be aligned to the goals to the appropriate data store. Okay. So processing big data, we will map the data to the programming framework and then we will connect and extract the data from the storage. Then we will transform the data for the processing. Then it will be Hadoop MapReduce. In Hadoop, if you see, MapReduce is the framework, like a heart of the Hadoop, we can say, for processing. And then employing Hadoop MapReduce is creating the components of Hadoop MapReduce jobs. We will distribute it and then execute the Hadoop MapReduce jobs. Actually, if I want to talk about Hadoop, it will take a long time because it is like an ocean. Okay, I'm just giving only the overview. So if you see the structure of the big data, we are going to deal with structured data, semi-structured data and unstructured data. Structured data means what? It is like a Word file, a proper format is there. PDF file, a proper format is there. Okay, that is structured data. Or you can take the database. Okay, if you take a table is a structured form. Schema is there. Semi-structured means you can say, what is that? XML files or semi-structured files. Okay, and unstructured means streaming data, CCTV sensor data. These are unstructured files. Okay, you can process all this type of data, financial transactions, all this kinds of data can be processed with big data. Okay, so now if you see again why we need big data, it is because it is not big data. Why we need big data techniques for dealing with huge number of data. If you see in 2003, the connected devices were 500 million and the world population was 6.3 billion. But if you see from 2010, you can see the connected devices number were more than the world population. So when we started having the internet in our mobile, if you remember that in 2009, okay, till I think some 20 years back, We had laptops, we had computers in our home, but we had internet only in our laptop. We never had the internet in our mobile. When we started having internet in our mobile, then we started this big data. Then we started creating the big data. Because in mobile we have apps, then iPad, other things. So we are creating lots and lots of data. So from that point we started having creating big data. So if you see, exactly it started from 2009. Okay, so now if you see, in 2015 also it was like 25 billion connected devices, 7.2 billion world population. Now the world population is 8 billion, connected devices are 75 billion. So now you can easily, it is obvious, right? Even in the future it is going to be very big, it is not going to shrink. Okay. So how is big data different? Because it automatically generated by machine. As I told you, sensor devices are creating more and more data. Even if I say this in IoT, when we use this cathode and anode, when I just plug in that sensor device, it is creating data. There is a temperature device, it's very small, and I can use this uh, Arduino. Okay, when I connect the Arduino, when I put this sensor device, temperature sensor, it is creating a data, right? So that is also a type of data. So when you have a sensor in all buildings and other places, so it is automatically creating data in the embedded engine. Okay, so this is an entirely new source of data because we are using the internet, and it is not designed to be friendly because text streams are there. Okay, and if you see that, if you download the Twitter data, you cannot understand anything. Okay, only when we see the messages or when we see the posts, we can understand something. But when we download it in data format, we cannot understand anything. It is like a streaming text. And so if you see, most of the data will not have much value. That's why we need that V. Okay, so only we have to extract the useful information. That's why we need this big data tools actually. Okay, large data, more data usually beats better algorithm, right? I can say that SVM is a better algorithm, support vector machine or a decision tree, right? These are the better algorithms, classification algorithm that works well for many problems. But if you have lots and lots of data, the size is very big, then sometimes it may not work well. So that's what here they say more data usually beats better algorithm. And how to store and analyze large data. This is the question from 2009 till nowadays. Okay. So now if you see data storage, the capacity. So why we didn't use this hard disk drive? So we know hard disk drive may have failure, right? So the capacity is 1 TB approximately. The transfer rate is 100 MB per second. So what happens? Why we didn't use this hard disk drive? Because if we have multiple hard disk drive, we can store the big data, right? But we didn't do that because if you have to process the big data, what happens? Suppose if I have some 100 hard disk, 100 hard disk is splitted, the big data is splitted into 100 hard disk and getting stored. If I want to access it, the transfer rate is very low, right? I cannot process it. That's the main problem. And then problems with multiple disks will be hardware failure. That's the first point. And doing tasks need to combine the distributed data. As I told you, if I have 100 hard disks, all the 100 hard disks, I will split my big data and get stored. And if I want to process the whole big data, it will be very tedious. Okay. So that's what Hadoop provides. Hadoop provides reliable shared storage. So HDFS, that is Hadoop Distributed File System. Okay, and reliable analysis stream. MapReduce is a framework. MapReduce is the analysis algorithm we use in Hadoop. So now if I compare with other system, the traditional RDBMS and MapReduce. So MapReduce is the framework we use in the Hadoop system. So the data size will be in gigabytes in RDBMS, but it will be in petabytes. It's a big data. The one disadvantage in the big data is it processes only batch processing. But in traditional RDBMS, it is interactive and batch processing. The Hadoop is not interactive. That is one disadvantage. Okay. And then if you see the updates, read and write many times. You can read and also you can write many times in traditional RDBMS. But in MapReduce, you can only write one time. You can read many times. You cannot update. It is because the big data is divided and stored in different computers. If you want to update, you have to update in all other computers. So that is a hectic schedule. Okay. And then the structure schema, if you see here, it is a static schema, and in MapReduce, it is a dynamic schema. Integrity is high here, here it is low, and scaling is non-linear, and here it is linear. So there is some advantage as well as there is some disadvantage as well. So why we didn't go for grid computing? Okay, hard disk, multiple hard disk will be a hardware problem, right? So we can use grid computing, right? So the grid computing means nothing but shared storage. Okay, it works well for predominantly CPU intensive jobs. Okay, but what happens, CPU, as you know that in operating system, CPU is the main thing. CPU has to give his time for all the jobs, right? So when we use this CPU intensive jobs, what happens when I want to, if I'm using this grid computing, in that case what happens, CPU will be busy doing some other job. So if I want to process the big data, sometimes it may have time or it may not have time. So this kind of problem is there. So that's why we are not using this grid computing as well. And they said there is another thing which is called volunteer computing. Volunteer computing means volunteers donate CPU time from their idle computers. Okay, so this work units are sent to the computers around the world. So this will be suitable for CPU intensive jobs, but there is another concern which is called security. Because if someone is voluntarily giving their space or something, there is a, because we are dealing with the real-time data, right? When we deal with the real-time data, there will be some confidential data. We cannot trust anyone, and we share the confidential data with anyone who is volunteering for service, right? So this is one concern. We did not go for this volunteer computing as well. So that's why we, the scientists, they found this Hadoop. So now if you see Apache Hadoop file system. So if you see the history of Hadoop in brief, it was created by dog cutting. So someone is creating noise. Can you mute yourself? Uh, Archana Das, please can you mute yourself? Okay. So history of Hadoop in brief, if you see, the Hadoop was created by dog cutting. Dog cutting was a scientist, the researcher, and the original name for Hadoop was Apache Nutch in 2002. Okay, it was an open source web search engine in the beginning. It was a part of this Lucene project, and then they call it as Nutch distributed file system. Like nowadays we use HDFS, it was NDFS in 2004. Okay, then they wrote the paper in MapReduce in 2005. Okay, and then dog cutting joined in Yahoo in 2006. Then officially they changed the name from Apache Nutch to Apache Hadoop project in 2006. And then the adoption of Hadoop on Yahoo, the team became big in February 2006. Later on, they published a paper, the Google published the paper, MapReduce paper. It became a huge outburst there. So Hadoop projects were, Hadoop is an ecosystem, okay. Hadoop is having MapReduce framework, and there are, you cannot do, MapReduce will do only key value pair processing. You cannot process many things in Hadoop. There are many tools available. Hive and HBase, they are like SQL. Okay, Hive is for data warehousing, HBase is for structured query processing, MapReduce is a framework, HDFS is for storage, Zookeeper is there. Zookeeper is for monitoring service. Chakwa is for analyzing the log files. Okay, Pig is high level scripting language. Okay, and Avro is like a streaming. As I told you, there are different file formats, right? All the file has to be serialized. The formats has to be serialized into one standard, then only you can process it. For doing that job, Avro is there. So in the beginning, Hadoop everyone appreciated, but later they found it will be very hard. So someone who is learning Hadoop, he must be very well, he must have a good knowledge of Java, then only he can learn Hadoop, because Hadoop is fully Java based. Okay, and he has to learn Pig, he has to learn Chakwa, Hive, HBase for different processing. For stream processing, it is Tome. So they found that it is very difficult, and they needed a simple one software for processing big data other than Hadoop. And also it should support different languages, not only Java, because Hadoop is fully based on Java. So if you are not having good knowledge of Java, then you cannot do processing of Hadoop with big data. So now if you see HDFS is Hadoop Distributed File System. So HDFS is the foundation of Hadoop, and hence it is very important component of the Hadoop ecosystem. Without HDFS, Hadoop is nothing. Okay, so it is a Java software. The features are like scalability, high availability, fault tolerance, cost effectiveness, and everything. So fault tolerance means, here I want to say something. So for example, you say there is a big data. Okay, the big data is divided into some 10 divisions. Okay, 10 parts. Part 1 is stored in one computer, part 2 in another computer. But what is the advantage is, part 1 will have 3 copies in some other computer. Part 2 will have, 2 more copies in some other computer. Part 3 will have 2 more copies in some other computer. So in case if one copy is missing, the duplicate copies you can take. Okay, so that is very helpful. Okay, so that's what it was very feasible. The fault tolerance, high availability. Okay, that's what we felt it is very cost effective, and these are the good features of Hadoop, we can say. So now if you see the components of HDFS, the components are name node, secondary name node, data node. As I told you, name node is like a master, data nodes are like slaves. Okay, so what this name node will do? So the name node will have maintain the metadata. Data nodes will have data nodes are also computer. Name node is also one computer, a cluster. Okay, so the different divided data, the big data will be stored in chunks in data nodes. Okay, so the name node will know that which part of the divided data is stored in which computer, which data node. Okay, the block information will be maintained by name node, metadata. And then there is a secondary name node. So the name node will maintain this FS image and edit logs. FS image means file system image, and then edit logs. Like whenever I open my Hadoop, it will say that this is the time the log operation was done. Okay, and there will be a snapshot image of the Hadoop. So that will be updated every time. So the data node will handshake with the name node for every 3 seconds. It will send the block report to the name node. It sends the heartbeat to the name node, that it says that every 3 seconds I am alive. Okay, actually this will be, I'm just saying for example 10 computers, but in real time if you see there will be 50 or 100 computers connected together as a cluster. So in that case, you say that there are 100 computers connected. If one computer fails, or you take that some 1,000 computers are connected, if one computer fails, then what happens? Sometimes we don't know that which computer has been failed, or which computer has been corrupted or something. So in that case, we need a software, or we need some leader or some maintenance right? Uh, for that job, we have Zookeeper. Zookeeper will monitor. It is like a monitoring service. It will send the name node that this particular computer has been corrupted. It is not responding properly. So we have to see some other computer like that. And name node is like a master. It will have FS image, file system image, and edit logs. So this FS image is a point in time snapshot of the HDFS metadata. Okay, as I told you, point in time snapshot means what is the current picture right now. So that picture will be maintained. So it contains information like file permission, which file is having read permission, write permission and everything, like how much disk space is available in which computer, in which cluster, and like which file has been modified, and what is the access time, what time the clients access to this particular file, all these things. And edit logs, as the name indicates, edit log means what time you access the computer, what time you access the Hadoop cluster, like that. Okay. So as I told you, secondary name node, what happens sometimes we will not open the Hadoop system for some week, 2 weeks, or sometimes 1 month. In times of vacation, we are not going to use it, right? In that case, what happens if the name node has not restarted for months? What happens? The size of the edit logs will increase. In that case, when you open the Hadoop after a month, immediately the name node will not wake up. The secondary name node will put the edit logs. So what happens? The name node downtime will increase. So to restart the name node, the secondary name node will come in action. So the secondary name node applies the edit logs on the FS image at regular intervals. Then it will update to the name node. Okay, so this secondary name node will come only when you did not open the Hadoop for a long time. Okay. So next is Apache Spark. I'm just giving only overview. I'm not going very in depth because it will become like a Hadoop session. It will not be the topic. So Apache Spark is the one. As I told you, Hadoop is based on Java, and there are many tools available in the Hadoop ecosystem. And the users and the researchers, they felt it is very hard for them to process. So then they found this Apache Spark. So this Apache Spark unifies all kinds of big data processing under one umbrella. Actually, Apache Spark supports 4 languages like R, Python, Scala, and Java. Most of them are using Python because most of the scientists and researchers, they feel Python is easy, right? And it has inbuilt libraries. So if you take in Hadoop, there is a different tool. You have to learn the tool. There are some commands you have to learn. It will take time, right? But here inbuilt libraries are there. You can just use the same library. Like in Python, we are using libraries, right? Like SQL, machine learning, graph processing, for everything we have libraries. So it gives good performance compared to the Hadoop. But one thing is, Apache Spark is like in-memory processing. So it is like a front end. Hadoop is a back end. You can connect Spark with Hadoop, HDFS. Okay, because HDFS is having a big storage, Spark is like a front end. It will process faster. So instead of going for MapReduce, you can go for Apache Spark and connect to the HDFS. Or even if you feel that Hadoop HDFS is also very hard, you can learn Spark, and the Spark you can connect to the cloud like S3, you can connect. Okay, so there are many storage spaces available. You can connect to that storage space. So Spark is having libraries for connecting with R, for connecting with any other language. So what it will do, it will help with the DAG scheduler, that is directed acyclic graph, query optimizer. They have this physical execution engine. Spark offers 80 high-level operators. It will be very easy for parallel applications. Okay. So one thing here you have to note about the Spark is faster than Hadoop MapReduce. And like every year, I think there is a competition in the data engineering competition. Spark won like Spark was 100 times faster than this Hadoop MapReduce. So that's why I think this Spark came in 2013 or something. So Hadoop was in high peak in 2012, 2011. Then Spark was faster because it is using the CPU in-memory processing. So it is a good one. But still, if you have the knowledge of Hadoop, then you go to Spark, you can. So if you start with a Spark, you cannot understand anything. So this is the one thing when you are learning about the big data. Okay. So if you see the sources of big data are the users, we are the users, we create lots of data through application, system and sensors. So these are all the things through which we are creating the big data. So mobile phones, microphones, reader, scanner, social software media, cameras, CCTV cameras. So these are all the data generation points we have for creating the big data. Okay. So big data analytics means nothing but analytics and analysis both are same. Okay. So examining large amounts of data, we will extract the appropriate information. Then we will identify the hidden patterns and unknown correlations so that we will get the competitive advantage. Okay. So this will be very much helpful for making better business decision. Okay. So that we will, it will result in effective marketing, customer satisfaction and increased revenue. So this is what we will get through the big data analytics. So types of tools used in big data analytics is distributed service. It is not only HDFS, you can go for Amazon EC2. Amazon EC2 means elastic cloud computing. Okay. You can use HDFS or EC2. Most of the companies are using EC2. And to have the good knowledge, you must learn about HDFS. So where the data is stored, it's a distributed storage, HDFS or Amazon S3. Okay. The programming model is MapReduce or other programming models you can use. And then the operations, what type of operations we can do, analytic and semantic processing. Analytics means analyze the structured and unstructured data and then gain the knowledge about the data. So actually the type of tools are very huge in big data. I have not listed all the tools here. You can also check what are all the big data tools. It will give a list of tools actually. So the applications, if you see, the first field to make use of deep learning, machine learning, big data analytics or data science, this is the healthcare is the sector, the number one sector. Then you can say unmanned aerial vehicle or driverless cars. These are the next one. Homeland security. Like almost all the fields they are using big data. The most benefited fields are healthcare and traffic control, trading analytics. Okay. So leading vendors, if you see, MPP architecture means massive parallel processing architecture. They are like high end, like we can say high processing, like huge processing. They have IBM Netezza, EMC Greenplum. Actually, this EMC Greenplum is a free open source for processing this high level data, Oracle Exadata. They use this commodity hardware. They also make use of RDBMS, full SQL compliance. Okay, so they use NoSQL as well as SQL. Okay, as I told you, the polyglot vendor solution. So these are the leading vendors. So again, if you see that the top level IT jobs or this big data, it has created 4.4 million IT jobs, and also they require like 1 lakh data scientists in the future. That's what they say. So if you are well versed in the big data analytics tools, then you can become a big data analyst successfully. So I will skip this because we have spoken enough about this benefits of big data. So now the greater availability of data repositories. So these are some healthcare data repositories. Other than this healthcare data repository, there are many repositories available. You can just search in Google also. For example, this is like a cancer data, cancer imaging, like medical data, other not only cancer, other medical data. These are the repositories you can go for. And they say that 1,500 research data repositories are listed. 458 are keyworded as medicine. Okay, so 1/3 of the data or the repositories are all medical data. So that's why I said healthcare sector is the one which got benefited through this deep learning, machine learning research. Okay, now I'm coming to the enhancing teaching practices and curriculum design. So now I gave you a full good introduction about big data and Hadoop techniques and other techniques. Okay, so how we can enhance teaching practices and curriculum design. So first of all, we are going to use predictive analytics. So predicting students' performance and dropout rates. So what we are going to predict? We are going to predict whether the student is going to excel or he is going to drop out. Okay. And then we use this natural language processing, NLP, for analyzing student feedback. Okay. And then we use this recommender system for personalized course recommendations. So these are all the three things first we will see for teaching practice and curriculum design. So algorithms, for prediction, we use linear regression. It is not only linear regression. There are other regression techniques like logistic regression, decision tree. Many things are there. But here we use linear regression, for example. Okay, for predicting the student performance. Then sentiment analysis using NLP libraries like NLTK or SPACY. So NLP is natural language processing, we all know. And in that NLP, the library NLTK, Natural Language Toolkit or SPACY, these two are the mostly used libraries for processing the text in NLP. And collaborative filtering for course recommendation. There are many other filtering algorithms available. Here we are showing collaborative filtering. So if you see, we are going to use this train test split. Okay, this is a model from sklearn library. And then linear regression. So mean squared error function we are using to check the difference between the actual value and the predicted value, or you can say that how well the linear regression model performed. Okay, so the data actually I'm not using a big data because now I'm not connected with my lab. I'm using the laptop, so I have taken only a simple example. Okay, so as you know, the sample data set PD is pandas, MP is numpy. We are converting it into data frame. The features are hours studied, attendance and grade. So these are the three features. So the target value will be grade. Why is the target value? I'm going to give hours studied and attendance in the training, and then I'm going to find out the grade. So train test split, as you know that we have to split the training and testing data. After giving the training, we will put the testing data and we will see whether we are getting the correct result or not. And random state 42, why we are giving this random state 42 means so that we will get the same split every time, because as you know that we will run the iteration many times, right? So when we run the iteration many times, what happens? We must get the same split. For example, if I have some 80% training, 20% testing, the same 80% training data should be repeated. It shouldn't get confused with other data. So the linear regression model, we are fitting, then we are predicting. So it will give you the predictions and then mean squared error. It will show the prediction, what is the prediction, and then the mean squared error. So actually the mean squared error value is mainly depending on the data. Here if you see, we have taken only very less data. There are chances that we may get some like erroneous data, because if you for processing any algorithm, you need a huge data, right? Even if it is ML, at least there should be a considerable amount of data, then only it will perform well. If you have very less data, it won't perform well. So if we are not getting a proper result, no need to worry, you can add more data and then you can check whether you are getting the proper result or not. So what it will do, hours studied and attendance. Okay, so how much hour a person spent and then what is his attendance score. Based on that, the grade will be calculated. I will show by running this. Just wait. So here I'm using this Google Colab. Okay, so in this Google Colab you can see this I will run it here. Takes time. Okay, so let's see what is the result. Yeah, so the prediction here is, I think, I don't know whether you can see this because the result is very tiny, the numbers are, the prediction is 89, mean square error is 2.5. I think for the student data 2.5 is acceptable MSE. If it is if you give a large amount of data, then if you get this MSE as less, then
This is the syntax, same like that.
okay, so this will be a good one. If you have less data, then if you get the mean square error is high, then it is not a good one. Then you have to run many iteration. The thing is, you have to give more data. That is the problem. Since we have less data, it won't perform that well. So now I'll go back to PPT. Okay. So now if you see the predictive analytics, it will use the historical student data. Okay, so how it is predicting? It will predict through the past experience. Okay, predicting the students' performance and dropout rates through the historical data. What is the historical data here? The grades, the attendance, the engagement. It will be easy. If you have only less data, it will be easy, right? When it comes to big data, if you take a whole university students, then it will be a tedious job for processing, right? Because by seeing the grades and attendance, easily you can say that whether he is going to pass or fail. But if the student numbers are increasing tremendously, then you cannot do it. You need a automation system. That's why we are going for the big data analytics. Okay. So what we are going to predict how well a student is likely to perform in a course and whether a student is at the risk of dropping out or not. Okay. So how does this predictive analytics work in education? First, it will collect the data. The data is nothing but the student grades, attendance record, online learning activity, assignment submission, whether the student has submitted the assignment on time or not. So these are all the factors. It will decide whether the student will do well or he is going to drop out. Okay. Process the data, clean the data like removing the missing or incorrect values. Then we will transform it into the useful format. So then we will apply the machine learning models. So what are all the machine learning models available? Regression model for predicting the student score. Classification model is also there. So those classification models will identify students whether likely to drop out or not. And decision tree, it will show the factors affecting the performance. Okay, factors means again the same thing, the attendance, the student grades, these are the factors. And we can take action. What action we can take? We can provide extra support. Suppose a student is weak, okay, then we can talk to them individually and we can have some extra classes and then we can improve their level, or personalized learning based on strength and weakness. So if you see in our university, what we will do, first of all, in the first class, we will show the syllabus and we will ask the concern about all the students, whether we can go through this, I mean, we can further move on with this syllabus or you have to, or you want me to like change the syllabus or something. So this is how we will do, and improve course design to increase the engagement. This is how we will do. We show the syllabus and then if they feel that these topics are going to be very hard or something, then we will remove those topics or we will give only less task from that topic. This kind of things we will do. So that's why predictive analytics is very helpful in improving the students' score as well as the faculty's engagement. Okay, so before going to this example, now it is 11:28, 2 more minutes are there. I'll give you a break. I will be back after 10 minutes. Okay.
Huh? You attended, no? This, we cancel. 2 to plus I give the marks,
So we are continuing after the break. So we were talking about this predictive analytics in education. So again, I'm going to give you another example. So imagine a school wants to predict which students may drop out based on the past data. Okay. So there is student A, B, C and D, and they have given their attendance score, assignments, and then like how many assignments they have completed, average grade and the dropout. So here there are 4 students, 2 of them are at the risk of dropping out, 2 of them are not at the risk. So usually we know that students with a low attendance rate and low assignment completion are more likely to drop out. So in this example it is obvious, but if we have a big data, it is going to be a tedious job, okay? Because some of you may think that it's very easy, why we need an algorithm for this, right? This is just an example. When we have lots of data, then we need algorithm. So this is the code, again the same kind of code. We are using this train test split. Here now I'm using logistic regression, and instead of mean squared error, accuracy score is the metric we are going to use. Actually you can do one thing, you can compare all regression types by applying the student data, like which regression algorithm is working well, or you can use mean squared error, mean absolute error, root mean square error, and you can see which one is giving you the good result and you can take that. Okay. So here the data is, attendance data is there, assignments completed, like 10 assignments are there. The first student attendance is 95 and he has assigned completed all the assignments, and his average grade is 88, and 0 means no dropout, 1 means there is a risk of dropping out. Okay. So what we do, we will give this 3 features, attendance, assignment, average grade, and then we will drop out as a like a target variable we will keep. So first we have to convert everything into a data frame, then X is the feature and Y is the target variable. The features are attendance, assignments and average grade. Y is the dropout. Then as usual we are splitting, 20% we are assigning for the test data. Remaining data we will assign as a training data. The random state 42, it will keep the same split for every iteration. Here we use logistic regression model and we fit the algorithm here, we fit the model here. So then we are making the prediction. So after making the prediction, what we are going to do is, for a new student, I want to predict. Okay. So here I have given the accuracy score is the metric, and then the prediction. So for a new student, if I give 75, 7 and 65. What is 75? 75 is the attendance percentage, 7 is the number of assignments submitted, and 65 is the average grade. So whether this particular student is at the risk of dropping out or not, by seeing itself we can say that he is not at the risk, right? Because he has good attendance, like assignments or almost 7 assignments he has submitted. So the result will be no, 0 will be the result because he is not at the risk of dropping out. So we can also check that. So now I will use this logistic regression and accuracy score instead of this mean square error. Okay, I run this code. These are the 3 features: attendance, assignment and average grade, and the dropout rate. Okay, then I will run this code as well. So now I will make the prediction for the new data. I have given 75, 7 and 65. 75% attendance, 7 assignments and 65% average grade. I want to check whether the algorithm performs well. Okay. So 0 is no, 1 is yes. It has given 0 because this student is not at the risk of dropping out. Suppose I will change the number here. Okay. If I give 20% attendance. So now what happens? It has to say that he is at the risk. It has to give 1 as the result. I will run it again. So now I am getting 1. I don't know whether it is, you can see this number, it is very tiny. 1 means he is at the risk of dropping out because the attendance percentage is very low. So it means our model is also performing well. Okay. I'll go back to the PPT. Okay. So how the model works? The model learns from the past student records because we have given that if it is high attendance and all assignments submitted, then there is no chance of dropping out. Okay. So it finds the patterns between the attendance, assignment completion and grades and dropouts. So then it learns. It predicts whether a new student is likely to drop out or not. Okay, by having this kind of prediction, what we will do? As I told you, we will identify the risk, at-risk students yearly. When we find them yearly, what we will do? We will provide additional support, okay, tutoring, counseling. This thing we usually do in our university because since it is a foreign university, many students used to have more attendance, like they will not come to the classes properly and so after 1 or 2 classes, we will contact them and we will ask them what is the issue, why they are not attending the classes. There are many factors actually because it is a foreign country. They are coming, they are very new to the country and each and every class, it is not like India. Even in India, they are adapting the system. The system is changing, but it will not be in the same class. For each and every subject, they have to go to different buildings. So some of the students are not aware of that, or some of the students they don't know which building they have to go. And since it is Korean, this language, only in the university they speak English. And this type of problems are there. Climatic change. Now it is a snowfall. So these are all the factors. External factors affects a lot in foreign universities. Okay. And then personalized learning plans, or if the student is having a problem with the course, then we can ask them, we can give them the easier task to solve. And also if they feel that most of the students feel that the teaching way, the way of teaching is fast, sometimes they tell me that I'm teaching very fast. So in that way, we have to slow ourselves and we have to improve our teaching as well. The faculty also need to improve. The student also need to improve. So this prediction helps very well for the faculties as well as students. Okay. Okay, now coming to the sentiment analysis of feedback using NLTK for basic sentiment analysis. So what is this? Sentiment intensity analyzer is a model from that NLTK. NLTK is Natural Language Toolkit. So we are going to import from the library, NLTK library, Sentiment Intensity Analyzer. So for this Sentiment Intensity Analyzer, we create a variable SIA. And then I'm giving only the feedback. Actually, for processing huge data, you can give a huge document like 1000 pages or 2000 pages documents. It will analyze very quickly. But here, for example, I'm giving only 2 feedback. One feedback is from one student, the course content is excellent. Another feedback is, I struggle to keep up with the pace. So one is positive, one is negative. Okay. And then as usual, the Python code for review in feedback. Feedback is the data, the list. Okay. Then we are using this SIA.polarity score. The polarity score is a function it will return the measure of sentiment from the word. Okay, so what is the measure of sentiment? Whether it is a positive review or it is a negative or neutral. These three are the things. Okay, the sentiment score will be positive, negative or neutral. So when I run this code, it has to say that whether it is a positive or negative or neutral. Okay, let me run this. One problem is brother. Connected. Okay. Can you hear me?
Yes, ma'am.
Okay, okay. So since I'm in India, I have to face all these things. In Korea, there will never be a power failure. Okay, I will run this NLTK. Okay. It takes time for running. So the main thing is sentiment intensity analyzer. This is the module we are using, model we are using from this NLTK library. And it has to give whether positive, negative or neutral. Okay. There are two libraries, mostly used libraries from NLP, NLTK and SPACY. I will show both examples. I don't know why it is taking so much time. Okay, let me tell you. This NLTK, it is using this VADR lexicon. VADR means value, valence aware dictionary and sentiment reasoner or recognizer. So this is a lexical based analysis tool. So that is the tool which is used in NLTK for analyzing the text. Okay, it will give you whether it is a positive text or a negative one or a neutral one. We'll run one more time. If it is not giving any results, then I will continue. I think it is because of the power problem here. let it be, no problem. I will. We'll continue with the PPT. Okay. So this is going to give you the positive, negative, or neutral result. That is going to the outcome. Okay. Okay, I'm sorry for any disturbance. It's because of the power. Okay. Now we are going to do the student feedback analysis using NLP SPACY library. So the earlier example was NLTK. Now it is SPACY library. In the SPACY library, the function it is using is N-core web SM. So what is this N-core web SM is? N means English. So that is like an English database. Okay. So all the English words, meanings, everything is already stored there. So whatever we give the feedback. So it will reference with this database and then it will give you the proper result. So the feedback here, great, but the assignments were too difficult. So here you can say that partially it is positive, partially it is negative, or neutral also you can say. The student is saying the course was great, but the assignments were difficult. Okay. So what we are going to do is we are going to use the NLP function, NLP model from SPACY library, and we are going to put this feedback as a fit function, NLP as a fit function, feedback as the input. And then as usual, we are using this for token, for loop in document, token.pause. What is this token.pause? Pause means part of speech tagging. So whenever you, I think you know about NLP, it will tokenize if there is a heavy, huge sentence or like a huge document, there will be a sentence. From the sentence, each and every word will be tokenized. Tokenized means separate words. It will separate all the words from the sentence. That is tokens. Okay, from the tokens, part of speech tagging means nothing but it will find the noun, which is the adjective. So what are all other subject, other things? Okay, noun, adjective, and other things. Verb. So that is the part of speech tagging. Here we are going to check whether which is noun and which is adjective, so that it will show you from the result. So it is going to say that course is noun, great is an adjective, assignment is a noun, and difficult is an adjective. Okay. You can also find some other things. It is not only for finding out the noun and adjective. You can use this other things also. Okay. We will see what are all the other possible functions. We used this pause. Pause means part of speech tagging. You can use the tokenization. For tokenization, we will use the function doc.text. Okay. It will split all the text into words. And then NER. NER means this entity recognition, recognizing names, subjects, institutions. For example, if I say Apple is doing well, it means Apple is doing well means it has to recognize that Apple is a company. Okay. And then dependency parsing. Dependency parsing means this is the function token.dep. So understanding the sentence structure. Okay. Like Apple should come first. Apple is doing well means Apple is a company, is doing well means Apple is not the fruit apple. Apple is a company. That's what it has to differentiate. It has to understand the meaning and the sentence structure. That is dependency parsing. Stop word removal. Stop word removal means keeping only meaningful words. Stop words means nothing but if I say like, or I can say that and the. So these are the stop words. Whenever you are dealing with a big document, you have to take only the keywords. You have to leave all these things. So these are the stop words. Okay. And then lemmatization. Lemmatization means converting words to the base form. So if I say studying, studying means the base form is study. Running, running means the base form is run. Okay, that is lemmatization. And then text similarity, keyword extraction, TF IDF means term frequency, inverse document frequency. This is also we are going to do. And then topic modeling. So these two examples we will see in the next slides. So these are the possible functions you can do with the spaCy library. Okay. So not only noun and adjective, you can also split the text. You can do the name, other thing, recognition and dependency parsing and other things. So sentiment analysis for student feedback. So what is a sentiment analysis? Sentiment analysis means it uses NLP to detect the emotions, whether the student is feeling positive or if he is feeling negative or if he is feeling neutral. So what you can do, if you want to do any NLP analysis, you can do only with the feedback, or you can do with the discussion forum. For example, if the students are having a discussion forum about the course or about what course they need in the future, then in that case you can use the NLP for that. But mostly we will use NLP in the feedback system only. So how it works in education, it will help university to analyze the student review, like whether they are frustrated or satisfied with the course, or whether the faculty has to slow down or they have to change the curriculum or any other thing. So it is very helpful. This NLP analysis is very helpful in the by using in the feedback system. So there is another thing which is called a text blob. You can use from the NLTK. Text blob means this will also analyze the sentiment. Okay. Here also I have some three feedback. So three feedback. What are all the feedback? I have the course was amazing and very helpful. I found the lectures confusing and hard to follow. And the professor is great, but the assignments were too difficult. Okay. So again the same example. So what it will do actually, the NLTK, the data, input data, it will do the pre-processing. How it will do the pre-processing? First it has to normalize, then it will do the tokenization, then it will remove the stop words, stemming or lemmatization it has to do, then vectorization. Then finally you will get the analysis result. So these are all the steps you will do. This is a full NLP process actually. Okay. So when we want to analyze the sentiment, we can say that for feedback and feedback list, sentiment, we are using this text blob library. If it is greater than 0, it is positive. If it is less than 0, it is negative. Otherwise, it is neutral. So when you run this code, it is saying positive and negative and negative. Let's run this code. Okay. Let me run this SPASI first. Okay. Okay. I'll run this one. Okay. This is another example I will show you. Actually, I didn't put it in the PPT. From the SPASI library, I told you that you can find noun and adjectives, right? Can you see my screen? Is my screen visible?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah. So Ncore Web SM, this is like a database English model. Okay, it will load the English model, and then I'm going to process this. As I told you, Apple is looking at buying UK startup for 1 billion. This is the text we have given, and what I'm going to do is I'm going to print the tokens. Tokens means it will take only the keywords. It will not take all the stop words. It will remove all the stop words. Okay. And then named entity recognition. NER means named entity recognition. That is what I am going to extract. So what is a named entity recognition? It means it has to recognize Apple is not a fruit here. Apple is an organization. So what is the outcome here? The tokens or Apple is looking at each and every word has been tokenized, and then the named entities, Apple is an organization, ORG I have got, and then UK is a GPE, it is a place, it's a named entity, okay. And then 1 billion is money. So from that English model, it recognizes that Apple is a company, 1 billion is a money, UK is a place. It's a geopolitical entity. GPE means geopolitical entity. It's a place. That's it. So that's what you can do with the text analysis using the SPASI library. Not only nouns and adjectives, you can do many things. Okay. And now text blob is the example I showed you. I will run that as well. Okay. So text blob is the library we are using, and we are using 3 feedbacks from the students. One is the positive, the next one is the negative, the third one is, let's see whether it is positive or negative. For analyzing the sentiment, we have this code, and okay. So the first one is positive. The course was amazing. I got the result as positive, and I found the lectures confusing. This is the code. I mean, this is the second feedback. For this, it is negative. The professor is great, but the assignments were too difficult. For this also, they have given positive. Okay. So the algorithm works well. I mean, the model works well from the text blob. Okay. Now, I will go to the PPT. Okay. Next, we will see recommender systems for personalized course recommendations. We have seen the dropout rate, how to deal with the dropout rate, predictive algorithms, logistic regression, linear regression. And then we have seen the sentiment analysis. Now, recommender system. What is the recommender system? So, which course will be recommended by the AI for the students struggling to select the courses? So, how it will recommend? First of all, the suggestion of the courses will be based on a student's past course. What course he has taken in the past and what similar students study at the same time, and also the ratings and reviews of particular courses. These are all the factors it will lead to course recommendation. So, for example, how Netflix recommend movies, because we all watch Netflix movies, right? If I watch sci-fi movies, it is going to recommend sci-fi movies. If I watch some thriller movies, then it is going to show me the top 10 thriller movies, all these things, right? So, in education, if a student takes Python programming, so the system may recommend ML, that is machine learning, as the next course. Okay. For example, if I say if a student is taking Java, so what will be the next course? It can suggest big data. Okay, because to learn Hadoop, but because mostly in the big data you will learn Hadoop. To learn Hadoop, you must have definitely you should have the knowledge of Java. Okay. So here we are going to use collaborative filtering. There are many filtering algorithms available. Here we are using collaborative filtering, okay, for course recommendation. So this system works with what similar students liked and also past enrollments and ratings. Okay, so for example, student A takes Python and machine learning. Okay, student B takes Python, but he has not chosen any other course, or he is waiting. Then the system can recommend machine learning because another student the same level has taken machine learning. Okay, so this is how it will work. The collaborative filtering will work. So if you see in this picture, there are two athletes. They have the similar levels. Like they are also both sportsmen. They take the same appetite, same salads or something. And if this one is taking some drink, energy drink, okay, this one has not taken. So what happens? Automatically the system will recommend, so this cyclist also to take the same energy drink. So this is how the collaborative filtering system works. So course recommendation using collaborative filtering. If you see the course recommendation, so here we will use this SVD, singular value decomposition. These are the functions from the surprise library. Then again train, test, split, accuracy from the surprise library. Each and every library have different functions. Okay, here the accuracy is the metric from the surprise library, and the data is student A, B, B, C, C, and D, D. What is the meaning? Student A has taken Python and ML. Student B has taken Python and data science. Student C has taken ML and data science. Student D has taken Python and ML. The ratings they have given 5, 4, 5, 3 for this courses out of 5. Okay. As usual, we have to convert it into data frame. Then we have to define the rating scale from the reader function. We will load the data. What are all the data we will load? The features are student, course, and rating. And then the training and testing data. The split is 25% of testing data. Then we will fit the model, singular value decomposition model for the prediction. Okay. So then we will compare the accuracy. Compute the accuracy whether the predictions, the actual value and the predicted value are same or not. So here they say the model accuracy is 0.95. The predicted rating for the student B on ML is 4. Let's run the code, because sometimes, you know, if the data set, we have less data set, sometimes the predictions are not well. Let me run one more time. Let's see, I have to run this again. I think it will take time. Okay. It's okay, let it install. I will continue with the PPT. Okay. So we have used collaborative filtering. For user item interaction data, we use collaborative filtering. Okay, like a student, the course interaction, we used collaborative filtering. And if you have a detailed item description, then you can go for content-based filtering. But if you want to make use of both the filtering algorithms, if you want to take advantage of both the algorithms, then you can go for hybrid model. If you have domain knowledge, they can go for domain knowledge filtering. Or if you want a strong recommendation system with a deep insight, you can go for deep learning. And for the network model, we go for graph-based filtering algorithm. So these are all the available filtering algorithms, case by case. Okay. I think for most large data, we go for collaborative filtering. So now we summarize this, how this student data can be improved. What are all the techniques? We use NLP technique for understanding the feedback. Okay, sentiment analysis will detect the student emotion, recommender system for suggesting the courses, and collaborative filtering for recommending based on similar students. So these algorithms, even though they are machine learning, they can be applied for the big data. Okay. So now we will see how we can empower the research through big data analytics. What we are going to do here is clustering technique to analyze research trends, and then text mining for literature reviews, and then predictive modeling for grant success probabilities. We use clustering, mostly we will use k-means clustering because for a larger data set, usually we will use k-means clustering only. There are other clustering algorithms available. Then for text mining, we are going to use this latent Dirichlet allocation, LDA, for topic modeling in research papers, okay, for analyzing the text. And then predictive modeling, decision tree here we are going to use. So in the earlier examples, we used this logistic regression, linear regression. And here in this particular case, we are using decision tree, okay. So clustering technique, as you already know, clustering, we have learned many times, clustering groups similar items together. Here it is going to group the similar research papers by the topic, similar topic. Okay. So how the clustering will help in research means, you can imagine that you have thousands of research papers, okay, and then some papers are based on machine learning, some on climate, some on renewable energy. Then what it will do, the clustering automatically it will group together it will categorize, okay, without any labeling. That is unsupervised machine learning algorithm. So if you see, this is an example, actually this is not a research example. This example I have taken from the internet. It says that annual income and spending score. You can just leave that part. You can see that this data points, or you can take as a research paper, there will be centroids actually. Okay, the similar items will be grouped together. Actually, this is a different aspect. What we are talking about, the research is a different aspect, but the theme is same. Okay, so the similar items will be grouped together. So next, if you see the text mining for literature reviews. What is text mining? Extracting the useful information is the text mining from a large amount of text. Okay, so how it will help in literature review? When you are writing a research paper, you review hundreds of papers, right? Nowadays, even in academics, those who are in industries also, they have to do research, and we don't have time. Even though we have to read many papers, we are not having enough time. There are many AI tools in the trend, like Julius AI is there, Lit Maps is there. What you can do is you can just put the paper and you can see what are all the trending papers, like the latest papers. You can download and you can get easily, like yes, someone raised the hand. Any doubt you have? Okay, we'll continue. So when writing a research paper, you will review hundreds of papers. So this text mining, what it will do means, it will find the common keywords and trends in the paper when you put all the research papers, and then it will summarize the important findings. This is the thing, you know, if there are some 25 pages, if you take the Springer paper or a Elsevier paper or what is that? SCI papers. Okay, so we don't have enough time to sit and read all those pages. In that case, you can just make use of this AI tool or text mining algorithm. It will show you the important findings. So what is the gist of the paper and what is the algorithm they have used, what is the outcome. Okay, and then also it will be very much helpful for identifying the research gaps from that paper, so that you can identify the research gap and find the solution. You can also devise a solution for that. Okay, this is how it will help, text mining for literature review. So if we use, for text mining, we will use this TF-IDF vector. What is this TF-IDF vector means? Term frequency, inverse document frequency. Term frequency means a term, a keyword, how many times it appears in a document. Okay. Inverse document frequency means like in the document, like how many documents are having the same similar keywords in a huge repository. So that is TF-IDF. So if a particular term appear many times, then it means that is a trending paper, or that is the trending term, that is the trending research topic, you can say. So that's why we use this TF-IDF vector in this text mining. So here we are going to use this sklearn feature extraction. This is the library, and TF-IDF vectorizer is the model, and I have abstracts. So just as I told you, I am not dealing with a very big data because it will take time. I have consider this as one abstract from one paper. This is another abstract, third one, fourth one. So in the first abstract, this paper explores the use of AI in healthcare for disease detection. So deep learning models are improving cancer diagnosis and medical imaging. This is another one. The third abstract is climate change is increasing in risk of natural disasters globally. And the final one is AI deep learning. So from this, it will take all the keywords, okay, and it will see how many times these keywords are appearing. It will use this TF-IDF vector. Stop words English. So what is the meaning of stop words English means? The file we are giving is in English. The language we have to specify. Okay, and then we will use the fit function. It will take out the feature names. So it will remove all the stop words and then it will give you the keywords. What are all the keywords here? AI, cancer, change, climate. These are all the keywords. So by extracting the keywords, what you can do, you can see that how many times the keywords appeared and which is the most frequently appearing keyword. Okay, that will help researchers to quickly find the relevant papers. Let me see. I'll open the Google Colab. Yeah. Now I will run this. So this is the previous example. Actually, it requires this surprise. Scikit surprise is not there in the Google Colab. So we have installed this, and then now I run this. Let me try one more time. Let's see whether it is predicting properly or not. Since the data is less, okay, the RMSE is 1.0, I think. Predicted rating for student B on ML is 4.25. Actually, the student B ML, what is the rating he has given for ML course? So if I see student B for ML course, he has given 5 out of 5, and in the prediction it is 4.25. So almost the prediction is fine, right? It is not having a huge difference. So we can say that if we add more data and fine tune it, then it is going to work well. So now I will use this TF-IDF vector, text mining, okay. What we are going to do here, TF-IDF vector is term frequency, inverse document frequency. Okay, we have got this, all the keywords. From the keywords, we can see which is the trending topic or which is the trending or which papers we can download. We can go further for analysis. Okay, next is predictive modeling for grant success probabilities. So what is the predictive modeling? Predictive model uses the past data, we know that already, and then predicting the grant success. So a university will apply for research grants, right? For example, if it is a huge, big university, they apply some 100 research grants. So some of them will be accepted, some of them will be rejected. So here we are going to predict what is the probability of getting accepted. So what are all the factors will be affecting it, whether the professor who is applying is successful in the previous years, like the factors like researchers' past success, funding agency's preference. Sometimes the funding agency will have limitations, right? Those who have applied some last year or some 3 years before, they should not apply, or there are many conditions like only these country people can apply, okay, like this, or those who have completed PhD recently, those who are doing postdoc, these type of conditions are there. And the proposal quality, sometimes they need like only 500 words for abstract, or the citation, like how like well you are citing the relevant papers, okay, or impact in the sense like how your research proposal is very much helpful for the society, like what is the solution you are finding from your research proposal, from your research project. So these are all the factors affecting the success of the grant, okay. So now predicting the grant success, again, we will use this SK-learn model, SK-learn library, train test split. Here we are using random forest classifier. Okay, random forest classifier is the algorithm we are going to use, ensemble algorithm, and then accuracy score is the metric. So the past success is 1, 0, 1, 1. It means 1 means accepted, 0 is rejected. Citations, impact factor, grant accepted. So these are the features we have. So as usual, we will convert it into data frame. So the X is the feature and Y is the target variable. Target variable is grant accepted. The X is the past success, citation and impact factor. These are the features we are going to use. As usual, we will split the training and testing data, train the model, make prediction, check the accuracy. Let's see. I will run this code. So the features are past success, citation and impact factor. These are the features, and the target variable is grant accepted. Okay. I have split the code. Let's see. Okay. Okay. So the prediction accuracy 1.0, 1.0 means, so mostly it will be accepted, but we are not having the proper input data here. Let's see. Okay. Someone raised the hands, Dr. Rayapati Siva. Do you have any question actually? Okay. So next is the k-means clustering for grouping similar research papers. So the k-mean clustering everyone know already. Maybe you have done the calculation in hand. We used to do the calculation, finding the centroid and other things. So we all know about this k-means clustering. It groups similar research papers, right? So if you input 1,000 research papers, k-means what it will do, it will find the topics automatically like AI, medicine, climate science, anything. Okay. And then it will group similar papers under the category names without any human effort. So this is the paper. This is the code we have. Again, the same thing I'm using, TF IDF vectorizer, and k-means is the model from the sklearn cluster. So here we have abstracts like deep learning, AI, robotics, renewable energy. So this is one abstract, 1, 2, 3, 4, 5, 6, 6 abstracts are there. Okay, and then we are converting it into numerical form. TF IDF vector, it will convert the raw data into numerical form so that it can be processed properly. The clusters, we have to mention the cluster. So we are mentioning only 2 clusters because we have only some 6 set of abstracts. Okay, if we have many like 1,000 papers, then we can give some 4 or 5 cluster. We are giving only 2 clusters and we have not named anything, right? It has to name by itself without human intervention. So it says that cluster 0 and cluster 1. It has not given any name. So cluster 0 is medical AI, medical AI. Cluster 1 is climate and renewable energy, climate and renewable energy. Let's see paper 1. Paper 1 is about deep learning models, that is AI. And paper 2 is about AI and robotics in modern healthcare. So this is also a medical AI because they said it is a modern healthcare. Renewable energy is crucial for climate change. The third paper is climate. Fourth paper is also about climate. Let's see, the fifth paper is medical AI. What is the fifth paper? Machine learning helps detect diseases yearly. Fifth paper is medical AI. Okay, so let me run the code and we can test whether the model is performing or not well. So I will run the code. Okay, I have 6 substracts and I have to see whether they are putting in a proper cluster or not. Okay, that's what we have to check. I think there is a difference. The second paper in the previous run actually that I copied from the from this Google Colab. Previously the second paper was in cluster 1, now it is in cluster 0. The problem with this second paper is it says AI and robotics are used in modern healthcare. Okay. You cannot put it in the renewable energy. Yeah. I think this is the one. The second paper is the one which is getting confused all the time. I will run one more time and I will check whether it is changing. No, it is in the same cluster, cluster 0. Okay, that's not a problem. The problem here is we are not giving enough data. If you give enough data, then the model will perform well. Okay. So if the clusters are well separated, you can go for k-means. Okay, or if you have a large data set, you can go for k-means. And if the data is hierarchical relationship, for example, hierarchical relationship means the same factor you can take. If the student engagement rate is high, then the score will also be high. That is the hierarchical relationship. If the student is having more absence, then the result is going to be low. Okay, so this is the hierarchical relationship. Then you can use hierarchical clustering for that. If you're dealing with the noisy data or outliers, what is the noisy data or outliers? Irrelevant data or missing values. Or for example, if the engagement time is 200 hours, so that is an outlier, right? So this kind of data, to deal with this kind of data, you can go for DB scan. And if the clusters are unknown beforehand, you can go for mean shift. And for the probabilistic assignment, you can go for Gaussian mixture models. And if you are having a complex shape, then you can go for spectral clustering. These are all the clustering techniques available mostly in the market. So next we are coming to the latent Dirichlet allocation. So this latent Dirichlet allocation is a topic modeling algorithm. This is also again used to discover the hidden topics in a collection of documents. Okay, so that assumes each document contains multiple topics. Okay, if it is a huge document, for example, some 1000 papers or some 200 literature reviews or something like that. So each document will contain multiple topics and each topic will contain words, right? Certain words. So this LDA, what it will do, it will see the probability of each word in the document. That's what it is going to do. So imagine you visit a library with hundreds of books, but no categorization. So your task is to identify the topics. How it will do? Each book contains mixture of topics like history, science fiction. Each topic will be represented by words. So this LDA, it will identify the topics and assign probabilities with two words in each topic. Like probability means how much is the level of that word. Okay, that is the probability. Frequently it appears. So how it will work? Each document is a mixture of topic. A research paper like discuss both AI and IoT. So the word distribution in the topic, some words are more likely in a specific topic like neural networks, mostly it will appear in AI paper. Sensors, mostly it will appear in IoT. So they have high probability. Okay. So this LDA assigns topic probability. It will estimate the words belong to the word topics. So finally the output will be the topic distribution. So based on that you can do this text mining. The research trends you can easily identify. So the simple example, consider we have 3 papers like neural networks, improve machine learning, big data and cloud computing are growing, deep learning and AI revolutionize technology. So the topics will be AI and big data. Under AI we have this words neural networks, machine learning and deep learning. Big data we have this words big data, analytics and cloud computing. So that is how it has to categorize and find the probability. LDA will assign the probabilities to the words in the topic. Okay, this is how it will do. So this is the example. I am not going to run the example. You can just, this code is easily available online. That's not a problem. So the same thing as I explained in LDA, it will run. Okay, the probability actually, the word, the particular word probability, how probably the word is appearing in a document. That is what the LDA will do. Okay. So if you see personalized learning with data science, adaptive learning means these days we are using online learning, right? Coursera, Udemy, Khan Academy, Duolingo, Smart Textbook, all these things. Coursera, they suggest courses based on the past learning. The Khan Academy adapts difficulty based on student response. Duolingo adjusts the exercise based on language proficiency. So they have this adaptive learning strategy. Adaptive learning strategy means nothing but, as I told you, the lead code. Okay, lead code will have different levels. So if the student is very weak, then you can give practice with the beginner level. If he is in the mediocre level or in the intermediate level, you can give training and he can pass on to the difficulty level, that is the advanced level. Okay, so the adaptive learning system works like this. This is the code for adaptive learning system. First, the question, it will start randomly for the student 1. So it will give the level like beginner, intermediate and advanced. If it is intermediate level, if the student is answering properly, I mean correct answer, then the question difficulty will increase. If the student is answering, he has not answered the correct answer, then the difficulty level will decrease. That is the adaptive learning system. That's what the code will explain here. Okay, that's what here. Adaptive learning, the system starts with an easy question and adjusts the difficulty level based on whether the student answers correct or not. If correct, the difficulty will increase. If incorrect, the difficulty will decrease. That's what the previous example code shows. Then case studies, if we take how the Coursera uses the big data, Harvard implementation, big data in academic publishing. So you can make use of Tableau also for data visualization. I'm not using this data visualization because it is very simple code, you can do it. So the Coursera, how they use the big data for enhancing the learning. They use this videos, as I told you, which video student rewind and skip, and how long the students spend on quiz, which questions students struggle. These are all the factors they will keep improving their Coursera videos so that the students are getting engaged or they are improving their level. Okay, and if you see in Harvard, so the key data Harvard collects is the login frequency, like how much time the student is logging in, and the reading time, how much time the student is spending reading their materials, and the discussion participation. These are all the factors used by the Harvard's use of big data. So if you see how big data helps in academic publishing, like AI scans thousands of papers, you can identify the duplicate research and fake citations and unethical research practices. Easily you can identify and you can overcome those things. So finally, if you see the enhancement for real life system is data collection, you have to collect the proper data, you have to analyze, use the machine learning models. And in terms of education, we use dashboards and we analyze the students level, and we will improve also the faculty level by this data mining techniques and other techniques. I will complete with this. Actually, there are many more things I didn't discuss. But I have tried my level best to discuss all the parts. If you have any doubts, you can ask me.
There is no raise hand.
Okay.
Okay. Thank you, Preeti ma'am, for such
Yeah.
an informative session. We
Yeah.
deeply
Thank you, ma'am.
appreciate the valuable knowledge you have shared with us today.
Okay,
And
ma'am.
it was the session was really insightful and gave us great perspective that will be helpful for our academic as well as research work. And once again, we sincerely thank you for your time and efforts.
Yes,
Thank
ma'am.
you so much, ma'am.
Yeah. Thank you for the organizing committee for giving me a chance. And I also learn many things when we prepare for the session. Okay. So thank you so much. Thank you for everyone. Yeah. Shall I leave?
And yeah, ma'am. Thank you, ma'am.
Okay. Yeah. Thank
There is
you.
an announcement for tomorrow's session. I would like to make an important announcement regarding tomorrow's session. As our speaker is joining us from Germany, we have adjusted the session timing accordingly. Tomorrow's session will begin at 1 p.m. We request all participants to take note of this change and join us on time for another enriching session. Thank you all for your active preparation participation today. We look forward to seeing you again tomorrow at 1 p.m. Have a great day. Thank you all.